Hello everyone. Today we are going to explore regression trees. These are a powerful technique in data mining and machine learning. Let's dive in. Welcome to our comprehensive look at regression trees. Throughout this presentation, we will cover several key topics. First, we will compare regression trees with linear regression models. This will help us understand their unique advantages. Then, we will explore the CART algorithm, which is fundamental to building these trees. We will learn how to make predictions using regression trees. Additionally, we will analyze their performance and discuss key metrics. Finally, we will implement regression trees using Python and scikit-learn. Let's start by comparing regression trees with linear regression. The key differences between these approaches are quite interesting. Linear regression works best when handling linear relationships in data. It provides easy measurement of statistical significance but struggles with missing values. It's also sensitive to outliers, which can skew results. On the other hand, regression trees excel with nonlinear data. They can handle missing values effectively and are more robust against outliers. They are also much easier to interpret visually, even when dealing with multiple features. The CART algorithm, which stands for classification and regression trees, follows a systematic approach. It begins by selecting a feature for splitting the data. Then it determines the optimal threshold for that split. The algorithm calculates the residual sum of squares, RSS, for each potential split. It evaluates all possible features and thresholds before choosing the split with the lowest RSS. This process repeats until meeting a stopping criterion. This methodical approach ensures we build the most effective tree possible. When it comes to implementation, Python's scikit-learn library simplifies creating regression trees. This code snippet shows how to initialize and fit a regression tree. It uses scikit-learn's decision tree regressor to handle the process effectively. Tree depth plays a crucial role in model performance. As we increase the depth, we need to consider accuracy and complexity. The coefficient of determination, or R-squared, helps measure model accuracy, while higher R-squared values indicate better predictions. Increasing depth can lead to overfitting. This creates more complex decision boundaries, which may reduce generalization. It's essential to find the right balance between simplicity and accuracy. When working with multiple features, things get more interesting. The CART algorithm evaluates all features at each split point. It chooses the feature threshold combination that minimizes RSS. We need to consider several stopping criteria, such as minimum samples per leaf. Additional criteria include maximum terminal nodes and maximum tree depth. This helps us maintain a balance between model accuracy and complexity. To wrap up, regression trees offer a flexible approach to modeling nonlinear relationships. The CART algorithm provides a systematic method for building effective trees. Tree depth significantly impacts model complexity and performance. When working with multiple features, careful consideration of splitting criteria is essential. Python's scikit-learn makes implementation straightforward. However, always balance complexity with accuracy for the best results. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.